Hello, my name is Brent Ferrier, and this is my final project for the Machine Learning Foundations class. So this is a regression problem. We want to predict a number, and I chose the metric of root mean squared error. Looking at the data, it looks like there's a strong negative linear pattern between the electrical energy output and temperature and ambient pressure. In addition, I saw some skewness in the data. So there were some transformations that I did to the exhaust vacuum. So I plotted those out on the right here, and I saw left skew in the exhaust vacuum. So I took the square of that variable, and I saw some right skew in relative humidity. So I took the log of that variable. I added those to my correlation plot on the left, and it doesn't look like it really increased the strength of at least a linear relationship with the energy output. So I don't think there'll be a huge factor on our final model here, but I did include those in my modeling process. In addition to those two transformations and creating new variables, I also looked at centering and scaling and using PCA for dimensional reduction. So I did a 80-20 train test split. I thought there was enough data that I didn't have to do a 70-30. In addition to the train test split, I also did a leave group out cross-validation. It's pretty similar to the K-fold cross-validation that we went through in class. The difference is that this randomly leaves out 25% of the data, and I repeat that 25 times. I have a AutoML script that I use for work. I've been a data scientist for 12 years now. So it wasn't much effort to test all of these different algorithms, and I tested them because I saw some strong linear patterns. So that's why I was looking at ridge regression, GLM stepwise regression, and lasso. And some of those also have some feature selection built in, but I also saw some non-linear patterns in the data, so I wanted to make sure I included some tree-based algorithms. So I've got decision tree, random forest, extreme gradient boost, but I also threw in kind of in between that the multiple adaptive regressive splines. This is kind of like a regression line where you put hinge points in so that you can be a little more bendy and capture the nonlinear patterns better. So for my train results, these were my top 10 experiments. The random forest definitely did the best, closely followed by the extreme gradient boosted trees. And then my multiple adaptive regressive splines are part of the Earth package, which round out the top 10 there. KNN was a surprise to me. I didn't think that would show up as high as it did. The random forest had really good performance, but they were by far took the most amount of training time. So if that is a factor in final production, I might choose a simpler model like KNN, which was really fast and easy to train. If there's a big performance difference. Based on pure accuracy though, random forest definitely was the winner on the training data set. And I looked at my original data, I looked at scaling my variables, and this was just z-scored transformations, and then principal component analysis on top of that as well to try and create new variables from that original scaled data set. For my test results, random forest also was the best on the test. A little bit different results though. So some of those models were probably overfitting, but random forest was the best on the scaled data set. I had a final root mean squared error of 3.49 on the test set. So it did go up a little bit, which is expected on data that the model has not seen for training. And I dissected that best random forest a little bit, and the most important variables are on the left in this bar graph here. So temperature by far had the biggest effect, quickly followed by the exhaust vacuum. The squaring it did have a little bit of help, but both were picked up as pretty important. And similar with relative humidity, both the log of humidity and the absolute score that we collected from the sensors was relatively about the same. I was surprised that ambient pressure wasn't picked up as important, but we're probably gaining the same information from temperature since both of them had a strong negative relationship. And that concludes my presentation. Thank you.